Welcome to the channel. Welcome. Today we'll be replacing the power cord. We will be reforming the caps off camera, and we will be changing this 1974 Super Bass to Super Lead spec without removing any of the original parts. So the coupling cap that's in it stays on the high treble channel. You can see the cathodes are tied together. There is no high treble cathode bypass cap or cathode resistor, and there is no bright cap across the one pot. However, you could see there's a 500 picofarad capacitor across the mixing resistors. We're going to put the cord right back where it is now. There's no depth cap. There's nothing to remove from this era. To be up to code for a new amp, you would give the green ground wire its own lug. However, I just want to restore it, make it as original as it could be. So we're going to put everything back right where it was. Reforming the caps required running it at 1/4 the operating voltage for 1 hour, 1/2 the operating voltage for 1 hour, 3/4 for an hour, and then full voltage for an hour. Worked like a charm. I didn't notice any current spikes or anything of that nature that was alarming to let me know that the caps would need replaced, so that's a good trick. It works well. I wouldn't have worried about it if the customer had used the amp more frequently, but saying it hadn't been run in 35 years required the reforming of the caps, in my mind. Okay, so we just take note. Where is the hot? Where's the common? Hot's closer to the outside of the chassis. Got out the solder sucker. Like to just clean and remove as much of the old solder as possible, and get those holes open at the end because I'm going to try to stick some wire in there, get a nice, good mechanical connection, even though they weren't connected that way initially. Pick off some of that. All of these solder joints are coated, and I like to pick off as much of that as possible. You don't want to get these switch contacts too hot, so I like the solder to melt and not anything inside the switch so it remains functional. Another thing we did was test all the tubes, clean all the pots, clean the switches. This is me hitting it with some acetone to get rid of any flux residue and impurities left on there. We want the best connections we can possibly get here. Now these are really hard. It's really difficult to get the wires out of these and get them squeezed out. The best way I found to do it is to remove as much as you can from the pinch point. So that means this I don't know what you want to call it, string, and maybe a wire or two if possible, will really just keep wiggling things out and give it a nice good squeeze. It's never easy. I don't know if there's a trick, but I know putting in the new one, it's handy to have some files around. And the new cord is, if your cord's a little bit fatter than the old one, you're never going to get it in there. So what you want to do is file away some of the pinch point plastic that's in there, and you'll get a nice good solid connection, or pinch rather, even if you do that. Works really well. It is in fact the only way. So I'll show you inside there a little bit. There's still some wires in there stuck, but you know, look how tight that was pinched on there. I mean, come on. Also, the impedance selector on this needed cleaned quite a bit. So I like to clean the fire-resistant powder off of the wires whenever I strip it, and then I like to shrink on a little bit of this tubing just to keep it from leaking out inside the amp at all. Let's give it the little heat gun. It works nicely. A little out of focus. I'll get better at that as time goes on. I didn't realize my camera was in autofocus. Decided to look at that nasty carpet instead of what I was doing. Now you can see I got the new one squeezed in there. And it doesn't move. It's perfect. So we'll get the ground on first. Strip everything. A nice mechanical connection. Can't stress that enough. Also, if you're going to work on these amplifiers, you need to take all the safety measures. You need to know how to discharge caps, not necessarily with this amp, but in general, you can die. So, let me just say this is not instructional. This video is for entertainment purposes. And just don't do it. Send it to a tech like me. You'd rather not die, right? Boom. On there, nice. Wrapped nice and tightly. Now, because that's connected to ground, it's going to take a little longer to get everything as hot as it should be, but don't do a bad job. You're not allowed. Get it nice and hot everywhere. I can't do nothing with you. Make sure what you're soldering to. Make sure everything you're soldering is equal in heat. And then you'll get a nice, good connection. We got the white wire wrapped on there really well. Leave yourself a little more slack than I did. Cut things about 1 inch long and then you can always trim them later. But I like to start with the wire, get it nice and hot. Solder shrinks up the wire a little bit. And then you get the switch contact nice and hot. And the two come together like they've always they were meant to be together. Boom. Look at that. Same thing over here. Boom. Okay, we'll take a look at the schematic here. You can see the cathodes are tied together. We're going to sever that. We're going to add a 4.7 kilo ohm cathode resistor and a 0.68 bypass capacitor. Also 1000 picofarads across the treble, the volume 1 pot there. We're using a vis-shaped cap because it's the right composition. It's polyester, and I like the old ERO caps, and this is the same company, so no need to go with anything hyped up in price or more expensive for no reason other than to say they're better. If you ask me, I only used the polyester because I wanted it to be similar in composition to the original caps. If I were building this amp, I'd use metallized polypropylene everywhere, almost. So, that's my hot take. I like WEMAs. If you disagree, I won't care. We'll get the board clamped up. I already got the resistor bent nice, so I'm like, okay, that's where it's gonna go. Not ready yet. Okay, so we got the board clamped up. This is a little technique I like to use that works swimmingly. Get the solder sucker above the board and then heat up the solder under the board at the contact. And you just suck it through the hole. Look at that. You would not believe how well this works. I didn't believe it was going to work as well as it does, but it does. I do this every time. So much better than actually raising the board and taking all the pots and everything else out. It's just silly. Unnecessary. Be very careful not to burn anything else while you're doing it. You can't see on the camera, but I'm crouched down to see under the board while this is going on. And you'll see resistor just drops right in. Look at that. Just a little wiggle, don't force anything. Remember that the board's old, everything in here is old. You have to handle it all with care. So I like to hold it in place. Use the pliers as a gauge of exactly where the hole is. Give it a little bendy. Here you'll see, just give it a little wiggle, a little push. Do not force it. You know, once it's in place, I'll use my pliers again to measure where the hole is on the other side. Pretty simple, straightforward mod. Doesn't deface the amp. Can always move it back to super bass very easily. One thing worth noting about the recording, the sound clips, they were done with the Suhr reactive load, so I didn't blow everybody up in the store that I work in. I work out of a prominent guitar store in Pittsburgh, where I do all the repairs there. So it's been around for a long time. It's worth noting that when you put that bright cap in, you're going to find one position on that volume knob that sounds good tonally with your guitar, and with these 6550s and the amount of output this amp creates, that's gonna be so loud. I put it in anyway, you know, but you're gonna want some kind of a reactive load to play in through, like a Triad power station, or the Suhr reactive load is really nice too. And find some other means to amplify the sound, because it's deafening, and should not subject yourself to that. I'm almost, I'm sitting here debating on whether I should even have the bright cap in, because then the amp can have a sweet, it's like, it can sound good in more than just one position of the volume knob, and so perhaps is more usable and versatile, but then again, you do lose that one sweet spot that sounds just like Led Zeppelin, so I don't know. These kind of things are highly subjective. If it were mine, I might take the bright cap out, but again, I'd never play out live with this thing. I mean, you just would kill people. It's unnecessarily loud. I have an amp that I built for myself, and it puts out 5 watts RMS, and I get yelled at because they say it's too loud, and I crank it. But 100 watts in a modern setting, bar gigs, it's not necessary. It's not even necessary in a theater. So this amp was meant for like outdoor events. My bass player uses a 700 watt Class D amplifier and plays right next to me. And can't hear himself with my 5 watts. So whatever. I've been yelled at multiple times by sound men. It's loud as fuck. Say. I'm like, dude, it's 5 watts. Go home. And that's just what I measured on the scope. I don't know how they rate these amps these days. It's like, this is 250 watts. It's like, no, it's not. A little out of focus. I'll get better with the camera as time goes on. Okay, we're back. Had an issue with the audio, I have no idea. Okay, so this wire here, I like to went in very nicely because we cleaned the tube socket contact really well, but what I like to do is get a bend on it so we have a little bit better of a mechanical connection. It's going to spread the wire apart a little bit. I try to get it in there, but it's going to need crimped in the other direction as well to be able to fit. What you don't want is any loose strands hanging towards the heater or towards the gate. And if you carefully wiggle it in there, you'll notice you won't have any issues. Just don't force anything. Be patient. If you have to crimp it again, you know. There's no need to rush. Move the camera so you can see a little better. When you're going to solder on a tube socket, remove the tube. There's not really any reason to put that heat stress on any of the elements. Looking good. So we're going to add the bright cap to volume 1. It's the same channel that we modified the cathode, and it's the same channel that has the bypass cap, or you could call it a bright cap across the mixing 470K mixing resistor. You can always use the reactance formula to find your corner frequency. Never burn a wire. Never burn a wire. That's the #1 sin in working on an old amp that you'd like to keep as original as possible. But as I was saying, 1/2 pi RC to find your corner frequency, which will begin to taper down. You'll be at -3 dB. At that point, we got a metallized polypropylene Panasonic capacitor. Excellent cap for this job. Way more reliable than a ceramic cap. One might say it's overkill. Make sure you leave some comments down in the section below. Let me know what I can improve upon, or how you'd like to see the videos change. I'm sure I'd like to get them shorter. I'd like to get the camera in focus more often. But this is just a start. We'll go from here, and I don't like to waste too much time on the footage while I'm at work, so this is just how it's going to go for now. We'll build things up over time. Look at that. Look how perfect that fits in there. Just get a couple nice little beautiful solder joints. Make sure you heat all three elements: the capacitor leg, the wire, and the pot connection. Look at that. Beautiful. All done.